6.2, day 1, we're looking at the law of cosines. We're going to use the law of cosines to solve oblique triangles with side, 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 or side, angle, side. Then we're going to use the law of cosines to model and solve real-life problems. So law of cosines, as we mentioned earlier, we're going to use that when we're given side, 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 or side, angle, side. We can't use law of sines. So here are the formulas for the law of cosines. So we have standard form on the left and the alternative form on the right. So on the alternative form on the right, that's when we want to find the angle. We are not given an angle. And then for the left, that is when we're given the two sides and the included angle. So let's try this example. Given three sides, find the three angles of the triangle shown. So we can't use law of sines, so we need to use the law of cosines. So one thing that we want to do is we want to use find the angle with the largest side opposite it. So for example, the longest side is b of 19, so let's find angle b. So let's do cosine of b equals, that's going to be a squared plus c squared minus b squared over 2 times ac. So cosine b equals 8 squared plus 14 squared minus 19 squared over 2 times 8 times 14. So then you plug it on your calculator. You would get cosine b is approximately negative 0.4509, and then use the inverse of cosine to find the angle, and so that's 116.80 degrees. So we have one angle. And so now what we want to do is we can use the law of sines now that we have an angle. So we can use sine of b. So let's find this angle A. So let's use sine of A over A equals sine of B over B. So to simplify that, sine of A equals A times sine of B over B. So A is 8 times the sine of 116.80 degrees over 19. Then you get sine of A is approximately 0.3758, and then you find that the angle A is 22.08 degrees when you plug it out in your calculator. Then the last part is to find C. So C, we know we can find that by doing 180 minus A minus B. So 180 degrees minus 22.08 degrees minus 116.80 degrees. Then you find that angle C is approximately 41.12 degrees. So find the three angles of the triangle whose sides have lengths A equals 6, B equals 8, and C equals 12. So to try this out, you would first find C, because that's the longest side, find the angle C. So cosine C equals A squared plus B squared minus C squared over 2AB. Then you find that angle C is 117.28 degrees. Then you would use sine of C over C. Let's find sine of A first. That's what I found first. So sine of A equals A times sine of C over C. Angle A is approximately 26.38 degrees. Then to find B, you take 180 minus C minus B, and then you would get approximately 36.34 degrees. So the angle that we should start with is you want to find the angle opposite the largest side or the longest side, and it helps us to know whether the triangle is acute or obtuse. So like in these cases, letter B is definitely obtuse, and then letter C is also obtuse. It's just good to know. Example 2, given two sides and their included angles, so side, angle, side. Find the remaining angles inside of the triangle shown. So this is where we want to use standard form. So we're given angle A, so what we want to do is we want to find side A. So A equals, or A squared equals B squared plus C squared minus 2BC times cosine of A. So a squared equals 9 squared plus 12 squared minus 2 times 9 times 12 times the cosine of 25 degrees. So when you plug it in, a squared is approximately 29.2375. Or and then you take the square root. You take the square root. So a is approximately 5.4072 meters, or just 5.40. Okay, or 41. So if we round. Then we want to do, let's use sine like we did before. So sine of b over b equals sine of a over a. So sine of b equals b times sine of a over a. So that's going to be 9 times sine of 25 degrees over a, which is, let's say, 5.41. And then you find that sine of b is approximately 0.7034, or angle b is approximately 44.70 degrees. So there are two angles when we have 0.7034. So we have B1, which is 44.70, and then we also have, we can find B2. So let's see, B2, remembering from the last section. So 180 degrees minus 44.70 degrees, and that's going to give you 135.30 degrees. Now I have 44.70, let me put that, 44.70 degrees, and then could be 135.30 degrees. Does that make sense? Now if you look at this, looking at the information that we have, what is the longest side? Well, our longest side is actually C, which means that the angle C must be the largest. So let's see what angle C is, and so let's do that. So let's find C first. So C equals 180 degrees minus A, which is 25 degrees, minus, let's start with 44.7. Well, let's do the largest one. Let's do 135.30. So let's just say, is it going to be 135.30 degrees? So when we do that, we find that C is 19.70 degrees. So let me just write that here real quick, 19.70 degrees. So if the side opposite C is the largest side, and that is given to us, then there's no way that C is 19.70 degrees, right? Which means that 135.30, this one here, does not make sense. So B2 is not one of our options. So we don't have to look at that. It's not possible that that is. If that were true, then the side B must be the longest out of all three sides. So I hope that makes sense to you. Okay, so in this case, this C2 does not work. So let's continue on with solving our triangle using the 44.70 as our B1. So 44.70 is our choice, and so let's find that C1. And so that's going to be 180 degrees minus 25 degrees minus 44.7 degrees. And so when we do that, we find that C2 is approximately 110.30 degrees. Okay, 110.30 degrees. And so that makes sense. Again, 110, that's the longest side, so here. And then you do need to look at that, right? Look at the comparison, see if that makes sense. So A, we found that to be 5.41 approximately. So that should be the smallest angle, which is true, 25 degrees, that's the smallest side. That 9 is the middle angle, so a middle length, so that means the angle should be between the two other angles, and C is the longest side, so therefore C is our largest angle at 110.30. So let's see, we have C2, or C1, sorry, C1 is 110.30, A is 5.41, and B1 is 44.70. So try this example. Given angle A is 80 degrees, B is 16, C is 12. Find the remaining angles inside of the triangle. So trying this out, you find that A is approximately 18.26. Then I found angle B next, which is 59.66. And now I know there's possibly two angles, so I just looked at the B first. And what I did is I wanted to compare the angles to the sides, right? So the largest angle should have the largest side. The smallest side should have the smallest angle, right? So that should be related. So I knew that C was the smallest side, then B, then A, right? Those are the largest angles. That should be true. And then the sides should be that same direction as well. So I found C, so B is 59.66, and I wrote it here. So that's smaller than A, which at least follows here, right? B should be smaller than A. Then C, when I plug it in, I find that it's 40.34 degrees. And so that is the smallest degree. And therefore, I know that this is the triangle that I am looking for, okay? I don't want B2. B2 would have been 120.34 degrees, but B is definitely not, the side of B is not the largest side, so that cannot be true. Okay, and again, I find that by doing 180 minus B1 of 59.66 degrees.